So we're going to tell you a little bit about the history of Office security, our approach to securing Office, and we'll give you some demos of both internal tools and some protections that we're delivering in the next version of Office, Office 2010. So the history here is our oldest threat was macroviruses. So you got like a Word document and you may have had some malicious macros in it, and if you enabled those macros, that macro document could go and infect other Word documents, and before you knew it, all the documents in your hard drive were infected with this macro virus, and you would give those files to other people who may also have gotten infected. So that was a little bit of a problem. The antivirus definitely started detecting that, and we made those scenarios a little bit better so that people understood some of the threats around macroviruses. Then around 1999, there were a rash of Outlook attachment issues and Activex repurposing issues. Does anybody remember the first big Outlook attachment issue, what the name of that virus was? Oh, a lot of people seem to love my presentation already, but that is not the answer I was looking for. There's something that happens before I love you. Melissa. Yeah, so Melissa happens in, I think, March of 99, and then about a year later, the I love you virus happens. So does anybody see a lot of those viruses happening today? Those attachment viruses? No, you don't. Do you know why? Users are smarter. That was one comment. One of the things that we did was we decided that executable attachments would not be allowed. So what happened in those cases of the macro or the Outlook attachments is you received something like a VBS file, and the user said, oh, somebody loves me, they want to open that thing, or I want to see the picture, or whatever. So they click on that VBS file, and that VBS file then runs whatever code it wants on the user's machine, and then it checks out that Outlook address book and sends it to all their friends, right? So instead, what we decided is that there were security prompts when the user received these VBS attachments. And they said, yes, I want to see this thing even though you're warning me about security. So we decided to block those things so the user does not have a choice. That's somewhat of an interesting choice. You'll see later in this presentation how we talk about the prompts not always being the best solution for security. Then prior to 2006, we saw very few malformed document attacks. And when I talk about malformed document attacks, I'm talking about fuzzing type issues like buffer overruns, double freeze, use of uninitialized memory. And then this happened. Guy finds a brand new Excel vulnerability. And what do you do when you find a brand new Excel vulnerability? You post it on eBay with your old socks and all kinds of other stuff, right? So this happened, and it drew a lot of attention that there may be some interesting vulnerabilities in Office. This happens at the end of 2005. And so I think this really drew a bullseye on Office, and people started to think hard about maybe I too can find some zero-day type bugs in Office. And shortly after, you start to see things like this, targeted attack using an unpatched Excel flaw. But it doesn't stop with Excel. The next one, we have a Word problem. Not to be let out, we have another Excel problem. We have a PowerPoint problem. The Excel one, we actually end up releasing a mitigation tool because we have these problems. And then, more Excel problems. And this goes on for a while. And when this happens, it is not fun at all. It's really not fun. There were like no jokes about this. Now, there are people in the audience, kind of joking and saying stuff like that. But when this happens to your product, you feel terrible. It's not fun. So this is how we're organized. There's a few centralized security teams, like the MSec team that drives the overall security process for Microsoft. They work with an Office Trustworthy Computing team. The Office Trustworthy Computing team is the team that I work on, and we drive the SDL, and the overall security goals and processes across all of the Office applications. We have security contacts on each of the product teams. So each of the product teams have a developer, tester, and program manager whose job it is to be a security contact. Their job is to tell us about security problems that they feel like might be in their application, and to work with us to help and mitigate those issues, and then also to train all of the developers, testers, and program managers on that product team so that those people that are building the features are knowledgeable enough to build it, code it, and test it for a security standpoint. And then the other team we have is the Office SE team called Capes, and then they work with any type of MSRC case that comes in. They work with the product teams to issue those patches. So in securing Office, we didn't want to just take one approach and say, hey, we have a bunch of fuzz bugs, let's just go after them. We wanted to look at this and lay our defenses, and the way that we do that is in 4 layers. First, we try to harden the attack surface, we reduce the attack surface, we mitigate exploits, and we try to improve the user experience, and I'll dig into each of those now. So in hardening the attack surface, we certainly are SDL compliant, and in many places will exceed the SDL. We use things like OACR, which wraps things like FXCOP and Prefast. These are code review tools. And then that code, those reports go directly to the developers that wrote that code so that they can fix that and learn so that they don't make those sorts of mistakes again. We'll also do things like when we see a common theme, like integer overruns are a common theme that we saw. We'll do things like create a code library called SafeInt to help developers write more secure code in an easier way. In a project like Office, you have many parsers, which we'll see in a minute or so, but you may also have duplicates of parsers parsing the same file format. So what we can do there is we can harden one of those parsers and reuse it in other places instead of trying to secure many parsers that do the same thing. And then the last piece that we do in hardening our attack surface is we do a lot of intensive fuzzing, and that's done in a distributed manner. So like I mentioned, we have a rather large attack surface from the file format standpoint. We have over 300 file formats. And many of these file formats are not obvious at first. For example, WPD, when you look at the file extension, you say, oh, that's a file format. It turns out that there's actually 3 file formats within that extension. In many places, we'll have smarter specialized fuzzers that know about the file format and ways to manipulate that in a specific way that understands the spec. And then one of the things that we found is very much in line with what was talked about in last year's BlueHat is different fuzzers find different bugs. And the more you fuzz, the more bugs you find. So we want to be able to put in as many different fuzzers as possible, and we want to fuzz as long as possible, as many iterations as we can. So one of the ways that we did to accomplish this is we built a distributed file fuzzing framework, and that was built by David. So one of the goals in that model that I talked about with the organization of Office is where we get every person thinking about security. We come up with interesting solutions that may not be thought about by the centralized security team. And in this case, David works on the access team, and he thought of this solution. So when you have this many file formats, you have some interesting things when you're trying to manage the SDL compliance around fuzzing. So each team has a subset of those file formats that are supported, and it's unclear from an overall standpoint how many iterations have been completed by each team and on each format. Machine logs often duplicate the same crash across machines and across runs and things like that. So it becomes time consuming to go in and understand that. And best practices that are discovered by one team may not be shared with other teams. And so you may have some people learning some really interesting efficiency things, but other people are not being able to take advantage of that. One of the other big problems we had was machine resources. What we were doing is we were leveraging machines in testers' offices. And so testers would manually configure machines to run the file fuzzer, and these machines were often used for doing the rest of their testing. So they would set up the fuzzer on a Friday, hopefully enjoy their weekend, come back in on a Monday, look at the logs, but a lot of times at that time they had a private release or something from the developer saying, hey, I need you to go and test this, so they would have to stop their fuzzing, and that's obviously not ideal. So this became a bottleneck. The machines themselves became a bottleneck for fuzzing. And then there was no way to easily leverage unused resources. So if the Word team finished their fuzz runs, the Excel team may not know that, hey, maybe I should go talk to this Word guy and I can use this machine when it's not being used and stuff like that. So now David will talk about some of the goals of the distributed fuzzing framework.
Thanks, Tom. I'm excited to be here to show this off today. This is one of the first big demos we've done outside of Office with DFF. So before I get started, I just want to gauge the audience a little bit. So if you could raise your hand if you've done any fuzzing or anyone on your team has done fuzzing. Could you raise your hand? All right, and keep your hand up if you're fuzzing across like multiple machines. Are you using just one machine, or are you using machines across your team? If you're using them across your team, put your hand up. All right, and then how about cataloging failures? Can anybody out there say they have every single failure they've ever found and can run them like on a minute's notice? Two. I also didn't see your hand up. Do we need to talk afterwards? Because I thought we had this all set up. All right, anyway, I don't come from Tom's team. I come from a product team, as he noted before. So this was built out of necessity. We actually used this on the last version of Access to ship it. So it was a big benefit there. My team came to me and said, hey, we need to meet the SDL. And you need to do it without spending any money. And I said, well, okay, I can meet the SDL, and I'll do my best to exceed the SDL. And I'm going to find a way to do it without spending any money, except you have to keep paying me. So that was the only caveat there. We've actually done this without spending any money. In fact, all the servers we use are recycled hardware. They're old hardware, so we don't have top-of-the-line servers because we don't need them. The framework's very light, and so we've actually been able to completely reuse. So today I'm going to go through DFF for you, and I'm going to go through it based on these goals that we have outlined here. So I'm kind of going to break down the system based on these goals and show you what it looks like. So let me start with these first three. Teams don't need to manage hardware. You can use any machine with Office installed on it for fuzzing. Now, of course, this is in the context of Office, but if you were not an Office team, you wouldn't need Office. And machines join in fuzzing with multiple products and runs. So how do we do this? This is the architecture of our system. So teams can take their resources and dedicate them in. I can tell my team, hey, I need your help with fuzzing, run DFF, and contribute your machines into our system. Those machines contribute into an infrastructure that's managed by TWC and the DFF admins. So the teams don't have to manage any of this hardware. They don't have to manage the backend database, the file stores, anything. That's all transparent to them. And these big, huge existing labs that we have, these resources can be shared across multiple teams. You know, one team isn't going to go try and figure out how they're going to leverage them. Everybody gets to use them, and they all plug into DFF transparently. And what this means is that teams in Office can use DFF without supplying any hardware resources. They can just immediately start using it. They don't even have to use their own team's machines, and they don't have to buy any hardware. So this is the actual DFF client that runs on the machines. And so the first thing I'll note here is that what we said before, we can contribute this to any team. So here we're contributing to TWC's work, but this could say all or Excel or PowerPoint or whatever team it would be. We made this very simple. So when I pass this out to my team can immediately begin using this and doesn't really have to figure out much. I spent the extra time to color code the buttons. I thought that would be easy. Most people understand a stoplight. I just tell them press the green button when you want to start and press the red button when you want to stop. Or you could press the yellow one if you're like, well, I'm going to go get coffee first, and you can stop on at some point. And then we added additional settings to the client to make it easier for team members to use on their machines. So you could think about this like if you stay up late, which I know a lot of security people do, and you have the TV on, you get all those infomercials, so you know the Showtime rotisserie grill. Same thing here. Set it and forget it. That's what we like to say. Because we have start on Windows lock, stop on unlock. So again, the tester can put it on their machine, set those settings, and they don't have to worry about it again. It'll just run on its own and pick up the work that it needs to do. So this is a view from the web of the system. And as we can see, this is just a small snapshot looking down. And some of the machines are dedicated to specific products like Access or Excel we can see here. And then some of those machines are dedicated to everything, like those machines that start with BB, which is one of our big labs in Office. We can also see the settings right from here. I can see the status of my machines. Maybe one has gotten hung up. I can kind of see what's going on from a high level here. And I can even move machines between teams and runs. So if I see as an administrator of the system that Access isn't really doing anything, and there's some machines that I own there, I can move those over to do work for Excel or for someone else. I can also control specifically the work. So literally I can kind of take remote control from the web of what those machines are going to do. Oh, and I will say, it says 556 million files we've done so far. We're a lot closer to 600 million now. So just churning through the files. And this is just one server. So that's how we met the first three goals. Let me go on to the next ones. So we wanted to be able to run any fuzzer, anything that generates files. We wanted a simple way to define a run. We didn't want people to have to know a lot about fuzzing necessarily to go in and get started. We wanted to just make it a very easy to use interface. And we also wanted to automate regression of previously found crashes. So that's where I kind of asked you, could you go through and rerun all your files? Well, in DFF, we wanted you to be able to answer yes to that. So teams have large sets of fuzzers in different combinations. Tom said we have 300 formats. My team specifically has about 22 formats that we parse. And so we have a lot of different configurations of our fuzzer to target specific files and specific types of files and parts of the file. And so we have hundreds of configurations in the system across many different types of fuzzers. And they're all, here's an example of some that are listed in this drop-down. And setting up a fuzzer is easy. You're just going to fill out a form. And we can do diffs of fuzzers. So this is great from a supportability standpoint. If for some reason there's a bug in one of the fuzzers that needs to get fixed, we can just make a fix to the fuzzer, and it'll populate back across all the fuzzers that inherit from that. So we're also conscious in space there too, where we don't want to have some huge fuzzers that we've just duplicated over and over again. We can use any fuzzer or any tool that generates files. So this is a simple example where we've just defined the arguments for for an exe, and away we go. It's that simple. DFF has some specific requirements of what your tool has to do just around generating files to a specific location and accepting files from a specific location, but that's really about it. So this goes further than just mutational-based fuzzers. If I have a generation-based fuzzer, I can easily plug that in here. We've had teams ask, hey, can I maybe not do fuzzing? I just want to generate a bunch of files and see if they work in my product. Well, you could really, in essence, you can do that here. And it's great for proof of concept fuzzers. I'm just developing a little tool. I want to see how it's going to work. We just plug it right in. You don't have to worry about any big framework that you need to sync up with. And we go further than just mutation-based random fuzzing. You can distribute Activex fuzzing we have here. So we do sequential fuzzing too in a distributed environment, and that's not pre-generated files. We do support pre-generated files, but in this case we actually distribute the generation of the files sequentially. Now I said we wanted to make the run definition very easy. This is an example of where we're going to define our runs. And we actually only have about 8 settings that need to be defined to create a run. We have different types of runs you can create. So you can create runs that are just generated. You just define it once and it runs one time and you get your results back and you're happy, or maybe not so happy. You can define runs that regenerate over and over again based on heuristics. So I define it once, it keeps generating over and over. Maybe when I investigate it, it regenerates itself. Maybe when a new build comes out, it regenerates itself. We have all those settings plugged into DFF so it can do that all automatically for you. Again, another one of those kind of set it and forget it features. We also, again, coming into the regression aspect of the system, you can easily define a retest of all previous failures based on maybe a call stack, based on a bug ID, based on just a run. And we'll take those failures both from your own product and any other product that defined that they had seen that bug as well, and we'll run them. And we'll run them in a matching configuration. So we're not going to use some random tool to actually test them out where it might or might not fail the second time around. We're going to use the same tool that we used before. We're going to try to use it on the exact same configuration that we had before so you get the best results possible. Because this came from a product team, I was specifically aware of how we worked on product teams and how we actually wanted to define our work. A lot of times we might have a bug that comes up that's kind of blocking our fuzzing, and we didn't want to waste time with machines, continually testing on that. So we have simple things like an application version filter to help make sure that DFF only runs on versions of the product that we want to run against. Choosing your fuzzers and templates is simple lists. We both have team-wide and public fuzzers and templates. So Tom might go into the system and define a new fuzzer that MSec released, and I can get access to that immediately. I might have my special configurations of my fuzzers from my specific product and my specific file types that other teams' Word doesn't really care about my database format, and they're not going to see those. And so I have my own list, they have their own lists, and we can easily pick those up. Oh, and also with templates, the same idea here. And the other thing that we're pushing is improved template selection. So this is kind of a bad example because the template set is 850 files. And we're pushing teams to have smaller sample sets or smaller sets of files that better represent the testing that they need to do. And so by having it in this nice, easy-to-use dropdown and having it indexed based off directory structures on some of our servers automatically again, teams can very easily define a rigid set of templates and very specifically pick what they want to do. Don't have to worry about losing templates, don't have to worry about losing fuzzers. And DFF aids in things like machine throttling for less powerful machines. So if I was trying to pass out to my team to have them do fuzzing outside of DFF, I'd have to say, oh, if you have a machine with less than 2 gigs of RAM, we're going to need to throttle a little bit, or if you have a slow processor. And DFF tries to do some work to help out with that automatically so we don't waste any cycles. That's one of the keys. We don't want to waste cycles and waste fewer machine hours by throttling a little bit. So the next goal, centrally manage all fuzzing jobs. And obviously we have a big web presence to manage just about everything about the system, but here's a look at the current runs page, which kind of lists out what work is going on. Now, what I see as a user for the Access team is going to be just Access. I don't see everybody else. It looks like this is my kind of private system. Now, Tom would see everybody's and can monitor the progress that's going on in the system. And we even added some additional filters, of course, to just help you out to better see what's going on. And as we look down this list of runs, we can see that we can monitor the progress, how far we've gotten. Now, you'll note that I kind of blocked out the failures column because I didn't want to give away any secrets here. But I can see immediately maybe that a failure has happened in that first run, for example, and I can begin to go investigate it immediately while it's running. So before, I'd have to set up a fuzzer and maybe run it over the weekend, and I'd have a good weekend and come in on Monday, and I'd get the results and have to look through those. Well, I can just come to this website and see, failed file. I'm going to go investigate it right now, as I'm running maybe during the week. We have some basic controls, so you can help move your runs around in the queue. You can privatize your runs if, say, you wanted to do some testing on one and didn't want the whole system to pick it up. And go in and easily modify your settings from here. I zoomed out a little bit in this screenshot. I wanted to show you what our queue looked like. So this is part of the queue, and then we have more of the queue, and then even more of the queue. So there's a lot of work that we place in our queue in Office. And this isn't a backlog. I want to clarify that we're tearing through this queue constantly. And just, this will be maybe a week, 2 weeks, I don't know. It depends on what kind of machines we have configured to get through it, because DFF is smart about how it deploys out its machines. But we also have hundreds of machines tearing through this work. So this queue we're constantly going through, and the queue is constantly regenerating itself. So we expect a big queue like this of work that we want to be done. And speaking of those regenerating runs, meeting the SDL is an important requirement. So based around my file formats, say I'm the Excel team and I want to monitor my progress on XLSB, I can take this quick view to see all the runs that were XLSB based on my SDL sign-off requirements and see, I'm getting up to that 100,000 mark, and I can monitor my progress on my failures right there to see that I'm doing a good job maybe, or maybe not doing so good a job of getting to the SDL requirement. Our final goals are around detecting duplicate crashes across runs and in Product Studio, which for those externally, Product Studio is our bug logging database, and automate logging crashes, or automate the logging crashes process to the bug database. And this is one of my favorite parts, so we're actually going to show you what the results look like. Before I show you the results, this is a screen that I can come in on Monday and immediately see what I need to do. These are the uninvestigated runs if I was the Word team that I need to take a look at. And the benefits here are that I'm not having to dig through these logs across all these machines. I just immediately see these results, and DFF goes a little bit further to try to help identify, so we see in that first run I found 5 failures, but only one of those failures doesn't have a bug. Maybe I've already assigned bugs to those, maybe they're kind of duplicated, and DFF thinks, these might all be the same, so you only really have one potential issue here to look at. So this gives me a quick idea of how my fuzzing is coming along and what I need to look at. And here's our results page. So right at the top, we give you some details about the overview of the results. I want to call out one thing in here, which is the unpost-processed count. When DFF generates the files out on the machines, if for some reason it can't run and test those files, we bubble them back up to our systems and hold on to them and then distribute them out to other machines. We try for every single file we generate to run it at some point across another machine. For sequential runs, we're very rigid about that. For random runs, it's possible that a file might not get run, but we do our best and we store those off. So if you see that you have some unpost-processed files, you can go in and run those if you're really worried about running every single file that was generated. We surface the same categorization based on the fuzzer. So the fuzzer determines possible exploitabilities and different things like that, and we just surface that up to the user. We don't make any determinations on our own. The tools have some great features built in, and we just expose that to the user so they can follow along with the SDL. Failures get hit across multiple products. We know in Office we have a ton of shared code, and so, or something like GDI Plus, we might perhaps have a bug there, who knows. And so we could quickly see that there's a huge hit count, and also then the file count just for my special set of files that I'm running here. And we collect these in a small sample set of files, so again, not to burden the hardware with too much, but teams can go in and say, I need some more files, and ask DFF for more files, and it'll collect additional files. So we're helpful in that regard. We have all the full details from the file fuzzer logs. We pull all that up and we parse it into a pretty UI, which I'm not going to show you today. But that includes EIP, fault address, instructions, registers, the whole call stack, listing of repro files that we have and we've stored off in DFF. You don't need to worry about where those go. We manage all those files for the teams. The dumps that were included, full, mini dumps, we have systems to deal with that too. For big full dumps can be a lot of storage, and how we deal with those. We have that all built into DFF. And what the OS version was, between 32-bit and 64, it's really important for me as a tester to immediately know that this bug was found in 32-bit or found in 64-bit or across both, and we can do that on our results page. DFF makes recommendations for bugs. So based on things it's seen before for other teams or your team, it might make a recommendation. So here it's thought, these 2 failures look like something I've seen before. And so this aids with me getting through my investigations a lot quicker. And we've added some bug icons for the testers to know the status of the bugs without even loading Product Studio. I can just go into my results page. Like for instance, this last failure might concern me because it has a little star, which means that it got fixed. Let's say it was fixed in a build before this build, and so now I know I need to look into why I'm still seeing this, and the dev told me it was fixed. We can easily log the bugs from here too. We just select the little checkboxes and click Log Bug, and it does it all through our system. We go into a web service called RoboWatson that we have internally, which presents this nice bug creation page. This really helps out with giving us consistent bugs for the devs. Everybody gets it in the same format across all of Office. It's easy for teams like TWC to come in and see what the bug actually is and what's going on there. And all the associated files get immediately attached. If you have multiple failures, we attach those. If you have dumps, we attach those. So the bug is ready to go for the dev to look at immediately as soon as it comes out of DFF. Turn it back over to Tom. He'll tell you a little bit more about the results we've had with DFF and who's using it.
Thanks, David. So the process, the tool that David built really cut down the amount of time it took for testers to do investigation. It used to be something that took many days for testers to do, and now it just takes less than an hour for the typical test contact to go in and investigate their product's failures. So we have many teams using the system today, and hopefully after today's presentation we may have many more. So Office is certainly using it. SharePoint, the SWI/MSEC team is doing some interesting things. Gavin Thomas is working on some stuff right now where when MSRC cases come in and we have to fix those, we want to make sure that there are no variants or bugs close in that area. And so they're using DFF to do that. And then there's some additional teams. So let's talk about results, because like Tavis talked about in his presentation previously, he wants to find bugs. That's the end result. He's not trying to write a thesis. We're not trying to write a thesis either. We're here to secure the application, and for us, part of that is finding bugs. So we have found a lot of bugs using this system. So if you look at Office 2000 RTM, we found around 1,800 bugs. Then you can look at the service packs. We found a little bit fewer in Office 12 or Office 2007, SP1 and SP2 were around 250 bugs in each of those service packs. And then Office 2010 for RTM, we're still taking fixes. That product's not shipped, but you can see that the count is quite high. We're over 1,600 fuzzing fixes today. So you might look at that number and say, wow, there's a lot of security problems. So there certainly are some problems, but there's some stuff going on behind these numbers. So we're very aggressive at fixing issues. So we don't spend time trying to figure out if these are exploitable or not. We just go and fix that issue. And if you just fix it, you don't have to worry about if it's exploitable or not, right? It's not going to crash anymore. One of the other things that we do is we just fix things even when we know they're not security problems. So if we see things like a pointer is initialized to null or a variable is initialized to null, and then we try to use that, it's just a null deref, and that's not a security concern, but it's a robustness problem. So we'll just go fix that. But we're finding bugs like that through fuzzing. So our next layer of defense is to reduce the attack surface. And we have two key pieces that we do with this. And the first is file block, the next is Gatekeeper. File block is the ability, we open many files, as you might have guessed from our 300 file formats. And many organizations don't actually need to open all of those file formats. So you might say, my organization doesn't need to open this very old version of a Word document. We don't use that internally. We don't expect anybody to send us documents like that. And if they do, I don't want the parser to kick in on that. So we have the ability, either through the registry or through group policy, to say, I don't want to open these files at all, or if they do come, they'll be opened in something called protected view, which we'll talk about in a little bit. The next piece we have is Gatekeeper. So we wrote the file format. We also wrote these documents that specify how the file format works recently and published those out to MSDN. So we know what a file should look like. Sometimes files coming in do not play by those rules. A lot of times attacks do not play by the rules when the file comes in. So we created something called Gatekeeper, and it runs automatically on open, and what it does is it has a set of rules and it checks that file out, and it says, it returns to the caller a Boolean value. Either this one succeeds and it plays by the rules, or no, it doesn't. And so what this does is it allows a couple things. One is it allows us to easily protect against unknown exploits, because we're not trying to put a rule in and say, oh, there was this MSRC case and let's fix this one problem. It's an overall integrity check of this is a correctly formatted file. And then if there are some problems, the way this technology works is we have an XML file that describes what our file format should look like. And that XML file is used to generate C++, and that C++ turns into a DLL that does not need to be localized, and that DLL is the one that makes the decision. So if there is a problem where there's like a zero-day attack or something like that, we hope that we can quickly tweak the rules to find that and quickly issue that DLL update. So we took all of the file attachments for the MSRC cases against Office since January 1st, 2007, and we said which ones are blocked by Gatekeeper. Gatekeeper will not be able to detect all types of attacks, but it turns out that it's very effective against the attacks that we've seen so far. So in PowerPoint case, we actually will detect and reject every single one of the MSRC cases that came in after January 1st, 2007. Word and Excel also pretty good. The worst case scenario is Excel, and that's 82%, and I think that's something to be really happy about if you can block 82% of the unknown attacks. So the next piece I want to talk about is what do we do, how do we mitigate some exploits? And that's what I referenced a little bit before in something called the Office Protected Viewer. And so what we've done is we have a sandbox version of Word, PowerPoint, and Excel. So there are different scenarios that will lead you into this sandbox. For example, if you open a file that fails the Gatekeeper, depending on what your policy is set to, you can either outright reject and say, I'm not going to open these files at all, or the second option is to allow them to open, but only open in the sandbox. We can say some things like, I talked about file block. One option is, again, to outright block that file. Another one is to say, I'm not going to let that open in the full version of Office. I'm going to make it go into the sandbox. We have this idea of unsafe folders. So if something is in the TIFF, it probably came from some internet application. The temporary internet files directory is the TIFF. And if it's there, then it probably came from some internet location. And so we'll open that in protected view. All Outlook attachments and anything that comes from the internet zone will also be forced to go into protected view. So how does this protected view work? Well, we have two instances of the application. We have a host process and a client process. That host process runs with full privilege to the system, and it owns the ribbon and the outer parts of the UI. We have the second process, which is the client process. It runs with restrictions. It's running in a sandbox, and it does the riskier things like parsing the document. So if you were to look at Office, up here is the host process. That's the one that's running with full privileges. And then down here, that's the client process. The client can communicate to the host through name pipe messages. So the core components of the sandbox are using restricted token, which first came out in Windows 2000, core Windows piece, the job object, which allows you to do some restrictions, and user interface privilege isolation, first available in Vista. So the net impact of the sandbox is you should only be able to write to places that you are explicitly ACLed to do that. And that's the sandbox being ACLed to do that. And you can read from places that allow everyone to read. So at the end of the day, you should not see scenarios where you receive a malicious document, open it in protected view, and it be able to own your entire system and drop a rootkit. So the key benefit here is we're not fixing bugs because we have this protected view. This is a last line of defense. We certainly do things like have NX, ASLR, GS, and all of these other defenses in place, but this is an additional layer that allows us to do that. And then if there are some false positives in Gatekeeper, we have some way that the user could open it and not just say, yeah, sorry, you're not going to ever see that file again. And then the last piece we have here is we want it to improve the user experience, and we want people to have good information when making trust decisions, and we want to avoid the user from having to make a decision between being productive and being secure. And certainly there are some areas for improvement with that. So before, you used to see a lot of prompts, and we'll show a few different scenarios that are different in a little bit. So we think that this is a very common experience in Office. You have an email attachment that comes in. Today we'll do Gatekeeper validation on it. And then depending on what the results of that are, you can be blocked outright if the Gatekeeper fails, and that's what you've chosen your policy to be. Or then we'll go into the sandbox viewer if everything checks out, because this is an email attachment. If the user clicks enable, first of all, we feel that a lot of times you receive an email attachment and you just need to look at it. You don't need to proceed any further. You don't need to edit that document. And so your experience is sandboxed in that world. If you do need to do some editing, you click edit or enable, and then you're in edit mode, and this becomes like your document. You're now moving into the full version of Office, and you can save that document and do additional things. If you made any trust decisions, like that had macros, and you decided that I need to enable macros, will not prompt you again when you reopen that file about macros. So then I have a few additional demos. So the first one is MSRC case, the same one that the Gatekeeper failed on. So this is the more end-to-end user scenario where you get this PowerPoint attachment. And so this is actually the MSRC reprofile that we received. And up here you see that there's this red bar saying that you failed the Gatekeeper. You're in protected view right now. You failed the Gatekeeper, and you can drill in to get additional details. And if you choose, you could go ahead and enable that. But we would not think that's a good idea if it failed. The next scenario is we have some targeted attacks, and targeted attacks happen when someone sends an email to the victim. And so one of the scenarios that we know about is when you go and speak at a conference, a lot of times you don't have a close relationship with the people that are organizing that conference. And so they send you email attachments. So they might send you the schedule or the PowerPoint slide template or something like that that you're supposed to use for that. So it's somewhat a trusted relationship, although a lot of times these mails do not come as signed. And so in this case, I want to go ahead and look at the latest schedule here. So this is opening up Word. And what you see here is that it's telling me that I'm in protected view, and the reason that I'm in protected view is this came through an email attachment. The next scenario is like how you can stop being a security geek and be unfriendly with your friends when they send you things like this and you just delete it. And people call you up and say, hey, did you see that thing? Wasn't it awesome? And you're like, yeah, I don't really open attachments. Like, how many times does that happen to us, right? And they're like, what's wrong with you? You're just a nerd. So, I get this email. Says, check these out, so funny. I'm like, yeah. But, this is a guy I know. So what I can do there is I can just click on it. The first thing that you notice is different from the Office 2000 experience or Office 2007 experience. There was no dialogue that said, hey, do you really trust this thing? And the reason why is we've actually gone into the protected view inside of Outlook. So this previewer is running also inside of the protected view. So we can see there's photon phasers being shot. Yeah, I don't know if you ever try to get stuck in there. This is a concerned kitten. So now you can tell your friends like, oh yeah, that was really great. You might have guessed I'm not like a big LOL Cats fan. But so the next scenario here is you get an email attachment, and first of all, you may or may not have had some plumbing work done recently, and you get this thing and you're like, wow, I owe somebody a lot of money, or so is the claim. I'm not sure about that. There's this invoice. I don't know what I should do. So I can go ahead and click on this. I'm going to go into protected view, and in this case, the Gatekeeper has failed. And in this case, it's not an invoice at all. And when you see an invoice, you don't ever need to go and edit that invoice, right? It might be nice to edit some of those invoices. So in this scenario, this is a targeted attack, and somebody's trying to take advantage of some vulnerability on the system. But Gatekeeper has detected and said, hey, not only are we opening this protected view because it came through an email attachment, but this one is particularly malicious. So I'm not even going to write back to this guy, right? He's a bad, bad man. So we feel like we've done a bunch of work, and we feel pretty good about the work that we've done. We've improved a lot of the security in the next version of Office, Office 2010, but we realize that we're not perfect. And so we know that external people, while we've continued to innovate internally, we know that external people aren't just sitting there and watching, right? We know that they're doing a lot of creative things. And so if you're external and you have crashing files, I strongly encourage you to send them to secure@microsoft.com. We don't even need you to figure out if they're exploitable, right? If you have a crashing document, send it to secure@microsoft.com, and our team will investigate that. And if that is a security problem, we'll issue a bulletin for that and give you credit in that bulletin. So the call to action, what we'd like is for people to do more fuzz iterations and to accomplish that by distributing their fuzzers. Internally, you can use DFF for this. We recommend that you fix crashes even if they're not proven to be exploitable. So there's robustness changes, and it turns out that a lot of times you fix bugs and you find out later that they were security problems. But you didn't know at the time, you just fixed it, and you just saved everyone a whole bunch of time. And then the last one, of course, is a shameless plug because of where we work. We encourage you to install internally. The Office 2010 beta is available, and we encourage you to install that and send us feedback. Externally, it will be available next month. And then I'd like to thank our team and many people who helped in creating the distributed file fuzzer, some of these features in Office, and the presentation specifically.